Welcome back. So far, we have been looking at problems in which we were taking percentages of total amounts. In this video, we're going to turn to calculating percentages in the first place. So we're going to use formula 4-2, calculating percentages from given numbers. So whenever you're calculating a percentage in this fashion, what you're going to have is a total amount of something, and then you're going to have part of that amount. And you're going to be calculating the percentage represented by that part of this total amount. To calculate a percentage, you simply take the fraction that the part represents, which is the part over the total amount, and multiply it by 100. So taking a look at example 4.7, it says, suppose there are 250 vehicles available for sale at a dealership, and that 182 of the vehicles are pickup trucks. What percentage of vehicles for sale at the dealership are pickup trucks? Round the final answer to the first decimal place. So at this dealership, there are 250 vehicles. That is the total amount of vehicles. Out of that 250 vehicles, we have 182 pickup trucks. So that 182 pickup trucks is the part we're interested in because we're being asked what percentage of vehicles for sale at the dealership are pickup trucks. So to calculate this percentage, we take that 182 pickup trucks, divide it by the 250 total vehicles, multiply that by 100, and you get 72.8. So we were asked to round the final answer to the first decimal place, and it comes out even to that decimal place. So we just throw that percent on, and we have our answer. Now let's reflect on this for a moment before moving on to the next example. What percent of the vehicles on the lot are not pickup trucks? There's a couple of ways to go about answering this question, but the easiest one is to realize that all of the vehicles on the lot is 100%, right? So all 250 vehicles represents 100% of the vehicles. We just calculated that 72.8 of those percent of those vehicles were pickup trucks. So I'm going to subtract off the trucks, and that leaves a remainder of 27.2%. So 27.2% of the vehicles at this dealership are not pickup trucks. Now we know from this problem that 182 of the vehicles are pickup trucks. We know that means 72.8% are pickups and 27.2% are not pickups. So how many of the vehicles are not pickups? Well, there are a number of ways we can approach this. The first way is to use the percentage 27.2 and the total number of vehicles 250 to simply calculate what number of vehicles is 27.2% of 250. Using our skills from the last video, we know we can do that by multiplying 27.2 divided by 100, which is 0.272, times 250. And what you get is 68 non-pickups. Of course, a second way that doesn't use percentages at all, just uses subtraction, is to take the 250 total vehicles minus the 182 pickups, which also gets you 68. So notice we can go back and forth between percentages and real amounts. In this case, the amounts are counts of pickups and vehicles, but you handle these just like you handle any other number. Taking a look at example 4.8, a customer surveying a florist's cooler noticed that 4 of the 22 arrangements available had yellow roses. What percentage of the arrangements had yellow roses? Round the final answer to the nearest whole number. Okay, so the nearest whole number means the ones place, because a whole number is one that doesn't have any non-zero digits after the decimal points. So here 22 is the total amount, and 4 is the part that we're interested in. That's the number of arrangements that have the yellow roses, and we're asked what percentage of the arrangements had yellow roses. So that's going to be 4 divided by 22. That's the part divided by the total amount times 100. Now this comes out with a repeating pattern in the decimals. It's 18.1818 and so on and so forth. This is actually repeating, but we are not going to use any of that is after the decimal points because we're asked to round the final answer to the nearest whole number. I'm just going to throw a percent on here so we're clear. This is a percentage here. To the nearest whole number, we'd be looking at the number in the tenths place to see whether it's 5 or greater. In this case, it's 1, so it's 4 or less. So we're just going to leave the ones place the same and leave off everything to the right in our rounding. So we get that this is 18%. So 18% of the arrangements had yellow roses. That's just a little less than 20%. 20% is 1/5. We could go through the same exercises we did in example 4.7. Here, the percentage of arrangements that do not contain yellow roses would be the remaining percentage after taking out the 18% that had. So that would be 82% of the arrangements did not have yellow roses. So if you're looking for yellow roses in your arrangements, this florist is not going to have a whole lot of choice, although 4 arrangements does provide some variety. Another major application of percentages in business is using them to measure change. Percentage changes are frequently used because important quantities like revenue, profits, or sales change over time. There needs to be a way to assess those changes, to analyze those changes, to compare them in ways other than just looking at the raw numbers. Percentage changes can tell you whether a particular quantity has increased or decreased and by how much relative to the original amounts. So we're going to use formula 4-3 to calculate percentage changes. To calculate a percent change, use this formula which says take the new amount minus the old amount, so that's the change, divide that by the old amount, and then multiply by 100. So order of operations applied to this, you don't see any parentheses on the top of that fraction, but you know that they are implied because of the way the fraction is written. New amount minus old amount is the numerator of that fraction. Example 4.9 says, a stock was priced at $82.03 per share on Monday. By Friday, the price had increased to $101.77. What is the percent change in the stock price over this week? Round the final answer to the second decimal. So on Monday, that is the original amounts. By Friday, which is later, the price had increased. 8203 is what we would call in this formula the old amounts. In this case, since it's a stock, I'm just going to call it the old price. And 101.77 is the new amount or the new price. What is the percent change in the stock price over this week? To calculate that, we take the new price, 101.77, subtract the old price, 8203, just applying formula 4-3, divided by the old price, $82.03, times 100. I didn't use any units in this calculation just because there are no units on the percent change. They cancel out. So we're just going to use the numbers. And we get a number with more decimals than 2, 24.064336 ... We're going to round this to the second decimal place. So we're rounding to the hundredths place. Since the digit in the third decimal place is 4 or less, we are just going to leave that 6 just as it is. And the percent change we've calculated here is a 24.06% change. So that is great if you bought the stock on Monday. Now notice that because the price increased over the time period, the percent change is a positive number. Because the new price, 101.77, was higher than the old price, this calculation had to come out positive. And a lot of times, if a number is positive, you don't write the positive. It's just assumed if no sign is given on the number. But when it comes to percent changes, it often is written. So for example, you could talk about a price increase. For example, the price change was plus 4% this quarter. But if you said instead the price rose by 4% this quarter, you wouldn't necessarily leave the plus sign on. So the context in that case, by saying rose, is telling you that it was an increase. So that's going to depend on context. But in any case, this is a 24.06% increase in stock price over the course of this week. Moving to example 4.10, the same stock opened the next week Monday at $101.77. So the same price it ended last week at. Instead of rising again, the price fell to $77.28 on Friday. What is the percent change in the stock price over this week? Round the final answer to the second decimal place. So now 101.77 is the old price. 77.28 is the new price. So using our formula, we take 77.28 minus 101.77 and we divide by the old price. Old price is 101.77. Multiply that by 100 to get your percentage. And what you get is negative 24.064 ... This is a percentage. We're going to round this answer to the second decimal place. So based on the third decimal place of 4, once again, we're not going to do anything to the 6 in the second decimal place. And what you get is negative 24.06%. Couple of things. The price decreased over this week, so the percent change comes out negative. Now, saying you have a negative 24.06% change is the same thing as saying you have a 24.06% decrease. Percent decreases can be written with the negative sign. For example, orders changed by negative 25% year over year, or without the negative sign if the decrease is explained in words. For example, orders fell by 25% since this time last year. Now, before leaving this example, I want to point out that example 4.9 and example 4.10 both had a 24.06% change. In the first week, the stock went up by 24.06%. In the second week, the stock went down by 24.06%. So thinking of percentages, you might think that the same thing happened, that somehow this stock reverted to its original place, but it didn't. In week 1, it started out at $82.03 per share. It went up 24.06% over that week to a new price of $101.77. The next week, it started at $101.77 and fell to $77.28. That's lower than it was at the beginning of week 1. How come the percentages came out the same? It's because the old price in each case was different. So the second week, our old price was $101.77. So a 24.06% fall from that is 24.06% of $101.77 lopped off. Whereas in week 1, you started out with $82.03 and 24.06% of that gets added on to make it become $101.77. So the original price means that these percentages, even though they came out the same, do not represent the actual same amount of money, and you should always take that into account when you are using percentages to understand what is going on with some quantity.